fine. Okay, 6.1. So we are going to talk now about nth roots. Nth roots. It looks like this. The nth root of A.
I was like, what? I was like, what?
Are we just 5.9?
Yeah, we are.
I'm not too sure about that, but I think since we just have 5,
Okay, nth roots. The nth root of A. N is the index of the radical. We have talked in the past about square roots, yes? Yes, we have. Yes, we have. We've talked about square roots, so now we're going to talk about maybe like a cubed root, or the 4th root, or the 17th root, because that sounds like a lot of fun. Hey, I was typing it. Did you see me?
yeah, I thought.
So maybe by the end of class. Okay, here we go. N is the index of the radical. We can rewrite the nth root of A as A to the 1 over N. And can anyone tell me why we might want to do that? You should just leave that out. Awesome. And now you have to kind of leave a little spot for N. Okay, why would we want, does anyone have any idea why we might want to write it as A to the 1 over N?
Because then you can,
Owen's talking. No pressure. No. What do we know anything about square roots? I mean about exponents. Do we know anything about exponents?
yeah, kind of.
Yeah, we do.
I know that if you multiply like A to the something times A.
Okay, Owen's got it. So we do know properties. You're going to have to be quiet. We do know properties of exponents. We do know a lot about exponents from chapter 5. So that might be a good reason why we want to write this as an exponent rather than as a radical. Okay, for example, if we're just rewriting and we wanted to rewrite the cubed root of 12, that would look like 12 to the 1/3. Now, if we think about square roots, what's the index of the radical of a square root? What is it on a square root? 2. Did we write the little 2? No. This is understood. It's kind of like writing a 1 in front of an x. You don't have to do that because it's just understood to be 1. Okay. If we are rewriting a square root, that would look like 12 to the 1/2. Even though there's no little 2 there. Okay, now we have the 8th root of 15 cubed. We're going to rewrite this to where it's all a fraction. So first of all, what does the 8th root of 15 look like in fraction form? 15 to the 1/8. All I did was change how the inside looks, right? And now I have an exponent to an exponent. What do you do with those? Multiply. So this is 15 to the 3/8. Okay, evaluating nth roots. It's kind of different if n is even or if n is odd. That's fine. There you go. Hmm? There's like an understood 2 here. You don't have to write it. We haven't written it before.
So it's not an understood 1?
Oh no. It's kind of like when you've written square roots before, you've never written a little 2, right? And you've been writing square roots a long time. When you write square roots, you don't ever write the little 2 there, do you? No. But you're actually, it really should be 2. Okay. Okay, if n is even and a is less than 0, so remember a is what's inside of Q. A is what's inside the square or the root sign. So if a is negative and you have an even root, like the square root of -4, what happens with that? We get imaginary solutions. So what we're going to say is there's no nth root. There is a root in the imaginary system, but there's no root in the real number system. What about if a is 0? So like the square root of 0 or the 4th root of 0. It's 0. We'll say the nth root of 0 is 0. And it gives us one real root. I'm going to add that here. I'm going to say no real nth root, because it does have imaginary solutions. And if a is greater than 0, how many solutions does it have? 2. Kind of like the square root of 4 is +2 or -2. There's 2 solutions. Either way, they're the same now. Okay, so if n is odd and a is less than 0, let's think about the cubed root of -8. What is the cubed root of -8? -2. Yeah, so you're asking yourself what times itself would give you -8, and the answer is -2. -2 times -2 times -2 is -8. What about +2? No, because +2 times +2 times +2 is going to be +8. So if it's negative, it has one real root. If a equals 0, what's the nth root of 0 ever? No matter what n is, 0. So it's still going to have one real root. And then what about if a is greater than 0? Like the cubed root of 8. There's still just one real root. So anytime that n is odd, there's going to be one solution. If n is even, then we could have no solutions, one solution, or 2 solutions. There's different possibilities. What do you mean? There aren't 2 solutions. Oh, there are 2 solutions for C, sorry. We didn't do anything with it. Yeah. And really the only time you're going to pay attention to this is when you're solving. So, yeah. All we did was rewrite C. Okay, example. Find the 5th root of -32. When we did square roots, we were looking for pairs of numbers that occurred. Do you remember that? We looked for pairs. We would take them outside of the square root and write them once. Okay, now we're looking for things that occur 5 times. Are you looking for things that occur, whatever the index of the radical is, that's how many times you want it to occur. So if we broke this down using a factor tree, what would we get? Huh? Well, there would be 5 2's. That's what I was hoping you would say. You would have -2 times -2 times -2, -2, -2. Because this is a 5th root, what occurs 5 times? -2, that's the answer. So the reason we were looking for pairs on square roots is because the index of a square root really is 2. Not, well, no, it doesn't have to be. Yes. Which one? This one? Well, we're looking for something that's going to occur 5 times. And if we break -32 down, we're going to get that -2 is what occurs 5 times. And it's -32, so can they all be negative? The answer is yes. What about the 6 root of 1? Plus or minus 1, right? It can be 1 or -1. If A were negative, it would be no solution. No real roots. For which one? Well, it doesn't need an I, because this is a 5th root. It's basically saying what times itself 5 times is equal to -32. And the answer is -2. If you multiply -2 by itself 5 times, you will get -32. The I is when, like the square root of -4, what do you multiply by itself to get -4? What do you multiply by itself? So if you pick 2, you got to multiply by 2. If you pick -2, you have to multiply by -2. You have to multiply by itself. So nothing. That's when you would use the I. Does that make sense? But we can find, is there something that multiplied by itself 5 times equals -32? Yes, it's -2. Okay? All right, rational exponents. A to the m over n. No. So we can write this as a to the 1 over n to the m. So basically undoing kind of what we said earlier. By undoing it this way, we could think of this as an nth root. And we might be able to solve this. So it would be the nth root of a to the m power. A to the negative m over n. What happens when you have a negative exponent and want to make it positive? You flip it, or put it on the other side of the fraction. So 1 over a to the m over n, which is equal to 1 over a to the 1 over n to the n, so we can break it up just like we did before, which becomes the nth root of a. For example, if we want to evaluate 16 to the 3 halves, does anyone just know what this is off the top of their head? 16 to the 3 halves. Probably not, and that's okay. I probably wouldn't know it either, unless I'd just done it like I did last period. Other than that, I probably wouldn't know. Alright, but we can break this down. So this becomes 16 to the 1/2 cubed. Right, undoing the exponent. Okay, what is 16 to the 1/2? It's the same thing as the square root of 16, which is 4. Do it. So the square root of 16 is going to be 4 or negative 4. So we'll say plus or minus 4 cubed. So 4 cubed is going to be 64, and negative 4 cubed is going to be negative 64. I mean, you can do plus or minus. Okay, you try this one. 8 to the negative 4/3. What'd you get? Okay, so we have 8 to the 1, or actually, sorry, we have 1 over 8 to the 4/3, which is 1 over 8 to the 1/3 to the 4th, which is 1 over 2 to the 4th, or 1 over 16. And this is how I want you to do this. Not enter in your calculator. Some of these are going to say solve without a calculator, and some are going to say solve with. So if it says without, then I want you to show all of these steps. Okay, because the root is odd. The root is 3. So that means that there's only one solution. Now here's something I want to say, and the book isn't extremely clear about this, but at some point this plus or minus business kind of gets cumbersome. That we always have to do these plus or minuses. And the reason I said earlier that you really only have to worry about this on the solving problems is on the solving problems you're trying to figure out what could x actually be. So x could be plus or minus if you have an even root, or if you're taking an even root. Now, when we're evaluating them like this, so this example I just said evaluate, and we said plus or minus 64. Really, if I wanted you to get the negative 64, I would have written this as negative 16 to the 3 halves. And that would have indicated, or when you get the answer, you would get negative 64. So that would be how people would differentiate between, do you want the positive or the negative one? I'm just going to make the whole thing positive or the whole thing negative. So I don't want you to worry about that plus or minus roots anymore unless you're solving. And again, it's a little bit unclear because even on some of your homework, the answers in the back are going to be plus minus, and some of them, when you evaluate expressions, it's not. So on the ones that say find the roots, that's going to want plus or minus. On the ones that say evaluate the expression, if they want you to put the negative one, they're going to make the whole thing negative. Okay, so on those, you don't have to worry about doing the plus or minus. On the solving, you do have to do plus or minus. Always on the solving. Always, always, always. No matter if you're in this class or not. Always on the solving. The other ones are going to be up to whoever's teaching. Or the book or whatever. Okay. Questions on the last two examples? Yes.
So, on the second step of the last one, is the exponent, like outside of parentheses, always
Yes. Because you want 1 over the denominator here so you can figure out what root it is.
how do you get one out?
This is a third.
How do you get one?
Because this is a 3 on the bottom.
Why do you get one?
Yeah, if you multiplied it back out, you would get 4 over 3. Okay. Okay.
So once you have that, how do you get
Okay, so what is 8 to the 1/3? What is the cubed root of 8? What times itself 3 times will give you 8? 2. So this is what was in the parenthesis before. The parenthesis just changed from 8 to 1/3 to 2 because that is what it's equal to. Okay, don't listen to his advice about just putting in your calculator because there's only certain things you can put in your calculator and get away with it. Okay. So someone is going to misunderstand and say, well, Kevin said put it in my calculator. I'm telling you right now, if you put this in your calculator and then you hit 2 a fraction, you'll get 1/16. If you write this equals 1/16 on your paper, you will get 0 credit. 0 credit. Okay. I'm just trying to make a point because someone's going to have heard you say that and someone's going to be like, oh, I'll just put it in my calculator. We're getting to putting it in your calculator. We're going to talk about it. Actually, that's like the next thing I'm about to write. We're going to talk about it. But on these that say evaluate without a calculator, you must show your work. You must show the progression of steps. So I know that you knew what you were doing. Yes. No, we're going to go over that. We're going to do an example like that, so you'll see what I want you to do. Does everyone understand these examples? Kind of, sort of. Awesome. Okay. So now, evaluate with a calculator. Example. 25 to the negative 1/3. You can go ahead and get your calculator out. You can use that. I hate that the light is right there. Every time I use my calculator, it's right in the middle. Super annoying. That says 25 to the negative 1/3 underneath it. Okay, there's two different kinds of calculators, or two different kinds of things that you have for your calculator. You could have what's called math print. I call it pretty print sometimes. You could have math print, or you could have classic view. Okay, so those of you with pretty print or math print, when you type this in, 25, and then you do the little caret, oh, I'm not on the right one. You can't see it? Okay, so if you have pretty print, yours will look like this. When you hit the little caret thing, it'll actually go into the, that's not what I wanted. Okay, hang on. Oh, good grief. I am.
That was funny.
Okay. Have you ever felt like your parents your parents tell you to do something, like while you're doing it, they tell you something else, and while you're doing that, they tell you about 5 other things to do, and you're like, okay, what do you want me to do? That's kind of how I felt just that last minute ago. Do I? Never. Okay. If you have pretty print, yours will look like this. When you hit the caret, it'll go up into the exponent for you. Okay, if you have classic print, I'm going to tell you how. If you probably should already have it set if you have it. Okay, so if you have classic print, it'll look like this. When you hit the caret, it'll just be all on the same line. You need to make sure, if yours is like this, that you put it in parentheses. The whole exponent has to be in parentheses. If you have a TI-84 and you hit mode, which again, because we clear calculator memory so much, it's just J and pretty print, but I'll tell you. If you go to mode, the very first one says math print or classic. You can kind of scroll through the list and see if maybe, or scroll up and see if it's there. I don't know. Whatever you like. Math print sometimes drives me crazy.
Oh, because what do you like?
When you do an exponent, I want it to just type one thing, and it'll stay there.
It'll stay there. I did it all the time when I was drafting.
And then you look and you have like 47 exponents. It's really annoying. Okay, listen. If you would like math print on your calculator, you can go see Mr. Vaughn with your cord, and he will put it on your calculator. If you want it on your calculator. Yeah. I'm pretty sure. And that could be a problem. Okay, so when you type this in and hit enter, you should get 0.341599 something something. Did everybody get that? Okay, next one. This is really difficult. Yeah. Sure I did. What was the answer? 0.34. Yeah, it's like 2 decimals is probably good. 3 at the most, I would say. No sig fig, nothing. 2 decimals is good. Okay, the 9th root of negative 230. There's 2 ways you could do this. You could either say, okay, this is going to be negative 230 to the 1/9. When you do that, make sure you put it in parentheses. Always in parentheses. The negative 230 part. Or you could actually type it in. So let's do both ways. The first thing we're going to do is type it in negative 230 to the 1/9. Make sure you use parentheses. Okay, here's my non-pretty print. I'll show you. Stay, hang on, I'm going to show you this. It'll take 30 seconds. The other thing you can do is actually take the root. So whatever root you're going to take, type that number. So the 9th root, so type 9. Then go to math, and you're going to choose the one with an X, which is 5. And then type negative 230, enter, and notice that you get the same thing. Okay, your homework is on the grid for 6.1. It was a week ago, but it's the same homework. Have a great day.